Welcome to this video. This is Dr. Kiran Derle, and in this video we'll see the fundamentals of LCM and HCF. Fundamentals of LCM and HCF. Let's get started. Find the HCF of 120 and 210. So 120 can be written as 10 into 12, where this is again, so here we also have 10 multiples, so we keep that like this. This is 3 into 4, 3 into 4, right? So let's get here 210, 10 into 21, and this 10 into 3 into 7, right? So common, what is common thing? 10 into 3, what is common? 10 into 3, 30 should be the HCF of these terms. HCF of these terms. If we are asked to calculate what is LCM of let's say, yes, 120 and 210, what should be the LCM, right? So again, 210 can be written as 10 into 21 first, so 2 into 5 into 3 into 7, right? 120 on the other hand is 10 into 3 into 4, as we have just seen. So this is 2 into 5 and this is 2 square, so this becomes 2 cube, 3 into this 5, right? So in LCM we take the highest power of common factor. What is highest power of common factor? Is 2 cube, right? What is this 3? Again, 3 is a common, highest power is 1 only. Highest power is 1 only, 3 is to 1. Again, 5 is common, highest power is 1 only. 5 is taken, so 7. Multiplying this will give us the LCM of these two numbers. I hope you are getting this point. Okay. LCM of these fractions. We know LCM of fractions. LCM of fractions. What is LCM of fractions? Is LCM of numerators. LCM of numerators upon HCF of denominators. HCF of denominators. I hope you are getting this point. HCF of denominators. Okay, so LCM of numerators 2, 3 and 5. What is LCM? It's 30. 30 is the LCM. So LCM of these two is this 2, 3, 3 and 5, right? 2, 3, 5. Nothing is common between 3. Nothing is common between all the 3. So LCM will simply multiplication of them, right? Nothing is common between them. I hope you are getting this point. Now HCF of denominators. HCF of this denominator 7, 14 and 3. Again 7, and even if you get one prime number, still your HCF will be 1. Among the given numbers, even if you get only one prime number, still your HCF will be 1, right? So HCF of these fractions becomes 30. I hope you are getting this point, right? LCM is 30. So 30 is the least number which can be divisible by all the three fractions completely. This is least number. Next number would be 60. Next number would be 30. But this is the LCM, least number, least common multiple, what we say. HCF of these terms. So HCF of fractions is equal to HCF of fractions is equal to HCF of numerators upon LCM of denominators, right? LCM of denominators. What is HCF of numerators? 3, 6 and 9, which is such a number which can divide, highest number which can divide by 3 also, 6 also, 9 also, that is 3. So HCF is 3, right? So HCF is 3. LCM of denominator. So LCM of 32, 10 and 16. What will be the LCM? Now, if you observe, 32 is a multiple of 16. I hope you are getting this point. 32 is a multiple of 16, and all the multiples of 30 will mandatorily be multiple of 16, right? Say for example 64 has to be multiple of this. 32 into 3, 96 has to be multiple of 16. All multiples of 32 are multiples of 16 because 16 is one of the factors of 32. So all the factors, see one more learning here, all the factors of 32 right, will divide all the multiples of 32. I hope try get this point clear, right? So we just have to check now for 32 and 10, because we know all multiples of 32 will always be multiple of 16. Now 32 and 10, we want that LCM, the end part, unit place, to be 0. So 32 into 5 will give us 0, right? That is 32 into 5 is 160. 160. 160 is the HCF, LCM of these denominators. So 3 by 160 will be the HCF, right? The options are, I guess, wrong. They are very much wrong here. So final answer should be 3 by 160. You can always go with calculation of LCM by division method and factors, but these are very common sense you can apply and you will get your answer. I hope this is clear, right? 3 by 160 would be the right choice, right? They are actually copy pasted in a wrong way. This was previous slides option, I guess. Okay, about the number of pairs which have 16 as their HCF and 136 as their LCM, the conclusion can be, okay, the pairs as 16 is their HCF, 16 is HCF, and 136 is LCM, 136 LCM. It cannot be, okay, no, it is not. Only one such pair exists, only two such pairs exist, many such pairs, no such pair exist, no such. Why see write down this statement in your workbook. LCM is always a multiple of HCF, right? LCM is always a multiple of HCF. Here we can see 136 cannot be divided by 16. So there is no such pair which will be exist whose HCF will be 16 and its LCM will be 136. This is not possible at all, right? Because of this fundamental thing. I hope this is clear. HCF of three numbers is 12. If they are in the ratio 1:2:3, then the numbers are, see, HCF is 12. So ratio is this. Let's say the numbers are A, 2A and 3A, right? And their HCF is 12. So this can be written as 12A, this can be written as 24A, this can be written as 36A. So the numbers would be 12, 24 and 36. Or with by using options you can always go, right? By using option, HCF of these three numbers is 12. This is highest common factor which can divide this and this, right? I hope this is clear. The HCF of two numbers is 16. Their LCM is 160. If one of the numbers is 32, then the other number is, we have very sweet formula here. HCF, let's say there are two numbers AB, HCF of AB into LCM of AB is equal to product of AB, is equal to product of AB. So the HCF is 16, HCF of two numbers is 16, the LCM is 160, right? And one of the number is 32. Find the other number. This number we have to find out. Okay, so 16, 2 and this 2 is 80. B is equal to 80. The other number is 80. That's my answer. Just a simple formula and will make your life easier, guys. 6 bells commence tolling together. Fine. This is very favorite question, right? So 6 bells tolling together and toll at intervals of this seconds respectively. In 30 minutes, how many times do they toll together, right? So first bell will toll at after 2 seconds, right? Then after 4 seconds, after 6, after 10, after 10, after 12, after 14, after 16, after, let's say, right? So these many seconds, or let's say 60 seconds, after 60, 62 and so on. So this is first bell which can ring after every 2 seconds, after every 2 intervals, seconds, right? 2 seconds interval. Bell 2 can toll at the intervals of 4. So 4, 8, 12, after 12 seconds, after 16, and so on, 60 also. 60 also, right? So this one, 6, 12, 18, after 18 seconds, like this, after 60 seconds also it will toll together. This fourth one, 8, then we have 8 is also there, fine. 16, 24, right? After 120 seconds, they are also 120 seconds. This is also 120 seconds. This is also after 120 seconds will toll, right? So why I'm writing this 120? Why I'm writing this? Because see, we have to this after one, exactly after 120 seconds, this bell will ring, this will also ring, this will also ring, this will also ring, right? So this is the first time they are tolling together. Why 120? Why 120 is the LCM of these timings, right? LCM of time taken by the bells, LCM of 2, 4, 6, 8, and 10 and 12. Now we know, if we are finding LCM now, right? So larger number is 12. Now 2 is a factor of 12. So all the multiples of 12 will definitely be multiple of 2. So we don't have to consider 2. Again 4 is a factor, right? So all multiples will be multiple of 4. So no need to consider 4. Again 6 is also a factor of 12. No need to consider that also, right? So we'll consider only these three. Only these three. Right, so 8 is nothing but 2 cube, 8 is 2 cube, 10 is 2 into 5, and 12 is 3 into 4, 3 into 4, or 2 cube, 2 square, what we can say. So LCM is highest power of common factor, highest power of common factor, that is 2 cube, right? So and remaining also. So this is 8 into 3 into 5, 8, 5, 40 into 3, 120 will be our right choice. 120 seconds will be LCM. So that means after 120 seconds, all the bells will toll together. I hope you are getting this. I hope you are capable of imagining these things, right? So all the bells will toll after 120 seconds. Now the tricky question is, like, in 30 minutes, how many times will they toll together? So we know, in after interval of 2 minutes, 2 minutes they are tolling together. In 30 minutes are like, thought will go like this 15 times, but 15 is not the right choice. See, when they ask in 30 minutes, that means they take when they have started at 0 seconds, when they have told at the very start second. So they have started simultaneously at this point, right, this point, and after 120 second, so in 30 minutes we are not considering this, but in 30 minutes we have to take into consideration. So total are 16 times they are tolling together, right? 16 times they are tolling together. Try to understand this, right? If the question would have been like this, that in 30 minutes how many times do they toll together, after starting, if this would have been the question after starting, then your answer would have been 15, right? But in this case it will be 16. Try to understand this thing. Fine. LCM of 87 and 145. Okay, fine. 87 is actually 29 into 3, right? And 145 is 5 into 5 to 10, and 5 9 45. Yes, 29. What is LCM is asked? So common is 29. Uncommon also, uncommon. In case of LCM, uncommon also. In case of SCF, only common, and that too of lowest power. Fine. So this into this into this. So this is approximately 30 into 3, 90 into 5, 450, and last place should be 5. My answer would be this. right? Answer is this. No need to multiply this. Hope you are getting this thing. The traffic lights at three different road crossing change after every 48 seconds, 72, 108 respectively. If they all change simultaneously at 8:20 hours, then they will again change simultaneously at what time? Again, time taken of LCM of time taken. LCM of time taken, that is 48, 72 and 108, right? So we have to calculate the LCM of this. What will be the LCM of this? 48 can be written as 3 into 16, which is 2 raised to 4. I hope you are getting this point. 72 is 8 into 9, right? 8 into 9, that means 2 cube into 3 square, right? 108 is 10 can be written as 27 into 4, that is 2 square into 3 cube. 2 square into 3 cube. What is LCM? What is LCM? First common prime numbers, highest power of common factors. Highest power of common factor. Highest is 4. Then 3 square, 3 cube, that is 3 cube. 3 cube. I hope you are getting this point. So this is the time taken, right? This is the time taken. Okay, so we have to calculate minutes also. Okay, in minutes also, no? Right? Sorry. So 2 raised to 4 into 3 cube, right? If you want to convert this into minute, we have to divide by 60, right? This is seconds. This is these many seconds after they will toll together. All the three bells will toll together, right? So divide by 60 we have to do. So this would be okay, fine. This will be what? This is 16 into 27 upon 60. So fine, this is minutes. Okay, this is in minutes we are going to get. So 4 15 3 3 3 9, sorry, 3 9 and 3 5. So 36 by 5. 36 by 5 is 7 minutes, and this is 1, remainder is 1, so 5 2 0.2 minutes. 0.2 minutes is nothing but into 60. If you do, you'll get in seconds, so that is 12 seconds. 12 seconds, right? So 7 minutes and 12 seconds. After this 7 minutes and 12 seconds, this should be our choice. Where it is that? Achha, sorry, 27. Okay, 20 plus 7 will be 27. Fine, no issues. 27, this should be the right choice. I hope you are getting this point. See, what the basic thing you have to understand is after how many seconds they will ring together, or whatever it is, ring together, right? So that should be LCM of time taken. How to calculate LCM is by this way. Try to prime factorize quickly, guys. Try to prime. This is, there is no big deal in prime factorization. So we are getting LCM of this. So these many, after these many seconds, they will all the three will toll together, right? So this is in seconds. But as the options are in minutes and seconds also, so we are dividing this by 60 to convert it into minutes, right? So we have got 36 by 5 minutes, that is 7 minutes and 0.2 minutes. So 0.2 minutes can be converted by multiplying with 60, so 12 seconds extra. 7 minutes and 12 seconds extra. So this should be the answer. I hope this is pretty much clear, right? So HCF and LCM of two numbers are this. If the first number is divisible by 3, then the first number is, okay, fine. So HCF is this and LCM is this. First number is divisible by 3, then what is the first number? Okay, fine. Let's start. So let's say first number is 264. 264 is the first number, let's assume. Is it divisible by 3? Yes. 2 plus 4, 6, 6 plus 6, 12. Yes, divisible by 3, right? First condition is met. Now, if HCF is 44, it should also be multiple of 44. It should also be multiple of 44. Is this a multiple of 44? Yes. 44 into 6, 6 4 44, 6 4 44. sorry, 6 4 24, 6 4, yes, this is multiple of, yes, and if it is multiple of 264, yes, it is a factor of 264, yes, it is factor of 264 also. So this can be the right choice. Let's check 132. Let's check 132. 132 should also be divisible by 44. Let's see. 44 into this would be 3. Yes, yes, 132. Yes, so it's a first condition met. Now 264, it should be factor of 264 also. Yes, 264 can be divisible by 132. Yes, this can be the number. Yes, so both A and B is the third choice, which should be the right choice. 33 cannot be the right choice because HCF of those two numbers A and B, HCF is 44. That means this is also divisible by 44. This is also divisible by 44. So if you take 33, which is not divisible by 44, this cannot be the answer. I hope you are getting this point. I hope you are getting this HCF and LCM thing, right? LCM thing. Okay, fine. The least number which is divisible by 12, 15 and 20 is a perfect square. Now this has nothing to do with LCM HCF. This has nothing to do with LCM and HCF. Okay, fine. But let's see how we can go ahead and do it. Or we can yes apply LCM here. Yes, if they want, if if it is their wish, we will definitely apply the LCM. See, which is the least number which can be divisible by this? Or else you can just check with the options here. In as far as this question goes, you can check with the, so least number we have to find. So least in the option is 400. 400 is not divisible by 12 because it has to be divisible by 3 also, which is not divisible, so it cannot be the right choice. 900, yes, divisible by 12, yes, divisible by 15, yes, divisible by 20. 900 divided by 20, 0 0, yes, yes, this is the least such number which is divisible by all the three. This is what you can apply in exam, but let us understand the concept also. Let us understand the concept also. See, what is LCM of 12, 15 and 20? What is LCM of this? 60? 60 is the LCM. Okay. How can we factorize 60? It is 15 into 4. So 3 into 5 into 2 square. 2 square, right? If we want to make this a perfect square, if you want to make this a perfect square, we have to multiply it with 1 3, right? 1 3, so this will become 2 3 square, right? We are finding a least number, and if number to be divisible by 3, their power should be even. Here we already have power even, but here the power is 1, so we'll multiply with 1 3 and 1 5. 1 5, this should be our least number, least perfect least number which is a perfect square and divisible by all the three, because we are starting with 60 only. 60 is divisible by this and this, right? So this number will divisible by all the three and is a perfect square also. If you do this, this is 9 into 25 into 4, 25 400, 100 into 9 is 900. I hope you are getting this concept also. But in exam, you, in many of the cases, see, in many of the cases you can just go with the options in LCM HCF questions, right? But just to understand, for our satisfaction, we are doing this stuff, right? Okay. The least perfect square which is divisible by 3, 4, 5, 6 and 8. Again, we'll have to find LCM now first. So what is LCM? If 8 we are considering, 4 is no needed. 6 we are considering, 3 is no needed, because all multiples of 6 are multiples of 3. All 8 multiples of 8 are multiples of square, and we are already considering this. So no need to consider this. So we are reduced to 5, 6 and 8. What is LCM of this? This is 2 cube. This is 2 into 3. This is 5. Right? So common, highest power of common factor, 2 cube. Here uncommon factors. 8 into 3 into 5. So 120. 120. So 120 and factorization is this. Factorization is this. 2 cube into 3 into 5. We want to make it a perfect square. We want to make it a perfect square. So this is 2 cube. we want to give it 1 2, so least number we are doing, right? So that's why 1 2 we are allotting to this will become 2 raised to 4 now. This will become 2 raised to 4. 1 3 is needed, 1 3 is needed, so this will become 3 square. 1 5 is also needed, so this will become 5 square. This is least such number which is divisible. Or else you can always go with the options. As I said, you can always go with the option. Is this divisible by 8? I don't think it is divisible by 8, right? So let's check here what we are getting. This is 16 into 9 into 25. 25 into 4 is 100, into 4 is 400, 9 4 36. 36 is the least perfect square which is divisible by this, right? Or you can go with the options also, as I said, right? I hope this is pretty much clear. I hope this is clear. 3 piece of timber 42 meters, 49 meters and 63 meters long have to be divided into planks of the same length. What is the greatest possible length? This is very favorite example of exams, guys. Greatest possible length. When you are getting greatest possible value, greatest possible length, greatest possible number of students, you are dealing with HCF. You are dealing with HCF. No need to think anything. I mean, anything extra. HCF, right? Greatest possible length. So you have divided into planks of the same length. HCF is highest common factor, right? So highest common factor of these three. I guess it would be 7 into 6. It is 7 into 7, and this is 7 into 9. The highest common factor is 7 only, right? But what is asked? What is asked? What is the greatest possible length of each plank? Is, yes, 7 meters. Because this should be equal also. Equal also. I hope you are getting this point, right? I hope you are getting this point. And okay, fine. No issues. Yes, done. Hope this is pretty much clear. If you have any queries, please post on QA section. QA section is there. Get the use of that, right? But try to understand these things first. Okay, 21 mango trees, 42 apple trees and 56 orange trees have to be planted in rows such that each row contains the same number of trees. We want same number of trees, HCF. One variety, yes, this is what you have to learn this question, this particular question. You have to understand this particular question, how we apply HCF in these kind of questions, right? Minimum number of rows in which above trees may be planted. How many minimum number of rows? So to find out minimum number of rows, we have to allocate maximum number of trees, right? But they should be same number and of same variety. So we are dealing with HCF of the given trees. HCF of these trees. What will be HCF? I guess this is 7 into 3, this is 7 into 6, and this is 7 into 8, right? Nothing is common in all the three. Yes, 7 is the HCF, right? So we can make T1, tree 2, tree 3. We can plant 7 trees. 7 trees here, 7 trees here, 7 trees, like this, right? Like this. So here in 3 trees we have this variety, right? This mango variety. In again 6 another rows, so we have 7 7, and we have apple trees over there, apple trees. So we are filling, we are actually considering all the condition. We are contains the same number of trees. Yes, 7 7 7, same number of trees. One variety only. Yes, one variety only in each row, right? So minimum number of rows would be 3 of this variety. We need 3 rows for mangoes, we need 6 rows for apples, and we know we need 8 rows for this oranges, right? So minimum number of rows would be 17. 17 are the minimum number of rows. I hope you are getting this point, right? This is what LCM and HCF is about. I would suggest you to, if you don't understand this, try to pause the video, try to understand the question first and then watch this video, right? I hope, and any queries you can post on QA, please. Thank you so much. Keep studying, keep building your career, guys. Thank you so much.